that's 39. Again, there's a reason you're doing this.
In a certain way.
Yeah, and you'll see that I think on page 2 here, but it's always good to ask why. But sometimes the answer to why is, well, we need this skill for something else that we're going to do later on. Like, it's not always this like, really mind-blowing thing. It's just, yep, you just have to do this. So let me know when you get all that down. We'll move on to number 2 here.
All right.
Okay, so the same thing for number 2. We build those factor ladders off to the right here. 3, 1, 15 is 3, 5, 5, 1. So it's 3 times 3 plus 3 times 5. So your GCF is again 3. That comes out. The whatever's left over stays inside. And then your check is 3 times 3, 3 times 5.
Okay.
So I don't know. Why don't you try either 3 or 4 on your own, and then we'll move on to the ones that I think that the reason your instructor's having you do this, which starts with number 5. So do you want to do 3 or 4 on your own?
I'll do 3.
Okay. Go ahead and work that out. Let me know if you have any questions while you're working it.
I also have a question so when you're trying to find the for 12, when you're using ladder method,
Yes.
You could put it in. Couldn't you put it in as a 3 as well? Because the 1 plus 2 would be 3. So couldn't you put it in as a 3 as well as a 2?
You have to start in the order of increasing prime numbers.
Okay. That's okay.
And you're to answer your question, yes, you're correct, but the order matters at some point.
Yeah.
And that's, I mean, you're gonna get a 3. It's just better to get it. I'm sorry, you're gonna get a 3 eventually. It's just better to get it in the order that you expect. In this increasing order.
So what I got for the thing wouldn't it be so you take the 4, that's the greatest common factor, and then you would put in the parentheses, you'd put a 4 plus 3.
Yes, exactly right. And then your check is to just come off to the right and multiply 4 times 4 and 4 times
16, and then 4 times 3 is 12. Okay.
Okay, we should move on to 5 now. And it's actually not much different than, it's really not any different. There's a letter which maybe makes it seem like this is different, but you're going to do the same thing with your factor ladders for the numbers. So you still come off and you got to do a factor ladder for 12, which you've already done, and then one for 28. Like, and it for me, I don't know if your teacher's okay with this. Like, if you've already done the one for 12, like we did in I guess we didn't do 12. Oh yeah, we did it here. Like I would just tell you to just write the 2 times 2 times 3 times b. Like you don't have to redo the ladder, but your instructor may feel otherwise. Two times 2 times 7. Okay. What is the GCF? What in terms of the numbers?
Hang on. 2. The greatest common factor would be 4.
Right. So you write a 4 on the outside, and then you ask, you say, well, what's left over? It's a 3b, 3 times b, plus a 7. And then your check is to take the 4 and multiply it by 3b.
Okay.
And maybe that's new. I don't know. Is that new to you? 4 times 3b?
No.
Okay. And then you also do
We
the
worked on
4.
this a little bit in class today as well. For the algebra. So. Also, I got some for these numbers, like for number 3, like we're simplifying it down to an easier way to do it, but would it be meant for larger numbers? Because I could do 16 plus 12.
Yeah, the idea is that you learn this approach so
and
that
then you can do it for larger numbers.
yes.
Okay.
And the choice here to use small numbers is only to help you like make this easier, I guess, to digest the first time around. And it's good that you asked that question. I mean, that's really, no one asks me questions like that. So I'm really glad you asked, because that 4 times 7 is 28. 16 plus 12 is 28. That's not the point. It's to do what you just said. Okay, so we should do another one here. We should do 6. It's a subtraction, but that doesn't change anything. It's still the same steps. You still got to find the greatest common factor between 25 and 5. You still got to make the factor ladders for 25 and 5. So it's 5 times 5 times m minus 5 times m.
Okay.
What is the greatest common factor in this one?
5.
It is a 5. Good. So 5 on the outside, parentheses, 5m minus m on the inside. And then your check, very important. Your teacher's very big on the check, right? 5 times 5m equals 5 times, well, this is where we're going to be a little careful here. It's really negative m. Your teacher didn't really, did she do here? Yeah. We'll just do times m, keep it simple. Just and assume that minus goes with it. This is 25m and 5m.
Okay.
All right, so do you want to try 7 or 8 on your own?
I'll try 7.
Okay. If you have questions, please ask.
So it would just would I use because the greatest common factor because 7 is prime, so then it'd just be 7 times m, and
X,
then
X in this
x.
case.
Sorry, yeah, x, and then would I just put would I just put the 7 in, or would I
Well,
just put the
well,
x?
well, I mean, here's what I think you got down to.
Because it's just the
You
7.
got down to 2 times 2 times 7, and your GCF is 7, like you said. But what's
Yeah.
left over? What goes to the right of the plus?
4.
4.
So would it just be x plus 4?
Yes.
Oh, okay.
And then your check is 7 times X, 7 times 4.
Okay. All right.
Okay, so we should do 8 because it's, I guess with this new topic here, probably one more practice problem would help you. Please try it on your own. Let me know if you have any questions, and we'll look at some of the review exercises. What's your greatest common factor here? Did you say 6?
Yes.
Good. And what goes inside parentheses?
That's what I'm trying to figure out.
Okay.
All right. So I don't know if this is right, but I got 2 plus 5 times k.
Yeah, that's correct. It's whatever's left over, right? Whatever,
Yeah.
you've seen me circle these,
Yeah.
whatever is left over, you end up putting down in the parentheses. If they're in 2 numbers, you multiply them, things like that. Great. So your check here, you got to check. Your teacher's big on that. Yeah, and there's reason for that. Like when I write software, I always check. That's leads to better products. And you'll see that these do work.
Okay. And got it.
Okay, so now the rest of the work here, you got a long division problem, 13, and then the rest are kind of GCF problems,
And
reducing
then
fractions.
there's also fractions.
Yes. So where do you want us to go here?
Let's just reduce the fractions.
Okay, let's do number 10. Presumably 9 will be slightly easier than 10. You have to build your factor ladder for both of these numbers. That's probably the hardest part, is figuring out, well, what goes into each of these numbers. So 65, 2 does not go in because it's not even. 3 does not go in because 6 plus 5 is 11, but 5 works. And if you thought to start with 5 to start, you got lucky because it actually worked. 13 is a prime number. Okay, so you go with 13 there. So 65 is 5 times 13. 91 is really, really tough. Okay. 2 does not work.
3 does not work.
3 doesn't work. 5 does not work. So you go to 7. 7 does work. And how do I know that? Well, I know that 7 times 10 is 70, and that leaves 21 left over. 7 times 3 is 21. I don't know that 7 times 13 is 91. I know how to get there, though. I know how to make that work. So you can do your long division as well, but it's the same idea. But that's the key here. So it's 7 times 13. The 13s cancel, and you're left with 5 over 7. Let's do 12 next. That's okay with you?
Uh-huh.
A lot of factor ladders. I mean, you're probably tired of them at this point. You've probably done a factor ladder for almost every number that you would ever get in this part of the course.
I'm getting really good at them.
Yeah, and that's the idea. You do enough of these things, you're like, all right, yeah, I think I know how to do them. So one thing that's nice is if you see the number appear. I don't know if you see my screen again. I know it probably got ahead of you here, but if you see the number again, you just replicate the ladder. Like, you don't have to reinvent what you've already done, especially if you know if it's right. You just copy it down, and maybe that's why they had you do this. So we got 3 times 3 times 3, 2 times 3 times 3 times 5. And then I should bring this down. 3.
I knew something looked wrong.
Yeah.
I was doing 11, which looks very similar.
Oh, yeah. Well, if you already started, you got an extra problem here done. But you can see that the GCF here is 9.
Okay. Hang on. Two.
Any questions on this one, August? I know I kind of got ahead of you on that, but
No. Well, I guess I just tell you what I got for the, or
for 11, I mean, I can tell you if your answer to 11 is right if you want.
Hang on.
We're really short on time, so I'm gonna just jump in here and tell you that the GCF for 11 is 5.
Yeah, so then I got it right.
Okay, I'm gonna stop the recording.